Hi, my name is Casey Martin, and today I'll be guiding you on how to get started with iMOTION 2.0 tools and devices. iMOTION 2.0, which I'll simply refer to as iMOTION from here on out, is a highly integrated solution platform that is dedicated to motor control. iMOTION products come with Infineon's patented and field-proven advanced sensorless or Hall sensor-based field-oriented control algorithm. This algorithm is implemented in a professional motor control engine, which we simply refer to as MCE, that eliminates the need for users to write complicated motor control algorithm code, and also helps reduce the time to market for variable speed motor drive product development. To start, I will quickly go over a typical motor drive setup, which I have here in front of me, and then review the latest features and usage of the MCE tools, which I have here on my computer. After that, I will demonstrate on how you can use these new features to tune and debug your motor drive setup, as well as provide you direction if you're looking for more information or to dive deeper into iMOTION. Looking closer at the table in front of me, I have a typical motor drive setup using one of our MADK control board and power board combinations. MADK, which you see on this case, stands for Modular Application Design Kit, and these kits allow you to prototype your system by running and tuning your motor drive setup before getting to the PCB and layout design stage of your project. Here, I'm using the eval M1 101T control board designed with the IMC 101T-T038 controller, and the power board I am using is the eval M IM231, which utilizes the IM231-L6S1B Intelligent Power Module, or IPM, which is hidden underneath this heatsink. If you're not familiar with IPMs, they are typically a three-phase inverter integrated with gate drivers and protection features to simplify your power stage design. This power board includes all the necessary circuitry to operate on an AC source, which is connected here, and output three-phase power here, which connects to your motor. These MADK boards are designed to be compatible with one another and easily connect through the standardized M1 pin connector here. The iMOTION control board not only outputs the PWM signals for each IGBT or MOSFET, but also receives inputs from the power board like your bus current and voltage, the device temperature, as well as fault signals. The micro USB port from the control board connects to a USB port on your computer, which allows you to configure your motor parameters, run your motor, as well as tune and debug your motor drive system with the iMOTION tools. Okay, we now have everything needed for our motor drive setup, so now let's take a look at the iMOTION tools and how to get this motor running. Before jumping into how to download the iMOTION tools, I want to first give an overview of what they are. There is a slide in this Getting Started with iMOTION presentation that I want to share to help me explain. This presentation is actually available on the website, and it goes over all the content I'm sharing in this video, so I highly recommend also referring to it for another form of guidance. So first, we already know what the iMOTION platform is, but what are the iMOTION tools? Basically, there are two downloadable PC-based applications called MCEWizard and MCEDesigner. MCEWizard you would use first, and it is a user interface for you to input your motor, hardware, and application parameters to configure the controller for your system. This tool guides you through multiple system and motor-related questions using pictures and diagrams to help explain what parameters are needed. Also, if you're planning to use scripting with your controller, there's an integrated script editor and compiler giving you the option to customize your application. With MCEWizard, you verify the parameters you have entered, as well as generate a text file with all the parameter information that is then opened in MCEDesigner. If you enabled scripting, a .ldf file that contains the script functions, as well as a .map file that contains the register information to be used with the scripting, is generated and also then opened in MCEDesigner. MCEDesigner is a user interface to program and communicate with your iMOTION controller, as well as tune, debug, and monitor your motor drive system. With this tool, you start and stop your motor, read fault outputs from your setup, and tune your motor drive performance by watching real-time visualized traces of the motor parameters. Really quickly, before showing you how to get the tools, I want to go over what iMOTION products are available. So first, you already know about the MADKs, which are designed with the iMOTION products, but what actual iMOTION products are there? So first, there's the controller only, which I showed in my setup with the IMC 101T-T038, but there are also iMOTION Smart Driver products, which is the controller integrated with a gate driver in a single package to simplify the system design, as well as smart IPMs, which integrate the controller into an IPM module. So you have the controller, plus the gate driver, plus the inverter, all within one package, simplifying your system design even more. All of these product options work with the iMOTION tools. It's just a matter of how integrated and what level of ease of use you would like with your design. Let's now move on to downloading these tools. You'll need to visit infineon.com/iMOTION. This will bring you to the main iMOTION webpage, and on the left you can see the content that is available. It starts with an overview, which you see right here, and then the product list, any highlights like new products or available material, documents, which includes things like the user manual, application notes, training presentations, boards, which is a list of all the MADK aids that are available with iMOTION products, tools and software, which is the tab that we need, videos, which is where this video is actually stored, and lastly, support that links to our tech support, forums, and FAQs. Going down to tools and software, we see 3 tabs. I will download the iMOTION tools first, and they are stored in development tools. To download MCU Wizard and MCEDesigner, just click on them. And as you can see at the bottom of my browser, they are downloading. These tools will download like a typical application, so you'll need to run the installer to install them on your computer. Next, you'll need to download the MCE software package for the iMOTION controller you are using. Since I am using IMC 101T-T038 in my demo, I will download this dedicated zip file. Before starting any new project, I always highly recommend downloading the latest version of the MCE software package because it includes the latest firmware for the controller, as well as the latest MCEDesigner configuration file. So if I open this folder I just downloaded, you see it contains the IRC file, which is the MCEDesigner configuration file I was just talking about, the map file, which is the default register map for the controller. And you will typically not need to implement this file. It is only needed if you want to restore the register maps back to default from a map file you may have generated with the script compiler. Next is the LDF file, which is the firmware for the controller you will use. And then there's a default parameter text file for reference, but you should never need to use it as you should be generating your own parameter text file in MCU Wizard that has been designed specifically for your system. Lastly, included in the zip file is release notes and a README that quickly goes over how to program and where to get additional material. So once you've downloaded, please make sure you extract this zip file to make the content accessible. And lastly, since I'm using MADK, I will also download the MCU Wizard system configuration files. This step, while optional, reduces the number of parameters you will need to enter in MCU Wizard. Basically, since the MADK board defines all my hardware for my motor drive system, a lot of my parameters are also already defined, and this file eliminates the need for me to enter them in MCU Wizard. We always recommend using the MADK board as the first step of your design, so with this I also highly recommend using these predefined MCU Wizard configuration files. As you can see, it is a zip file with all the various MADK power board names. Just extract the folder and then you only need the file that matches your MADK controller and power board combination. So here I am using the eval M1 101T for my control board and eval M1 IM231 for the power board. So this is the file I will need. Okay, so that's all you need to download. Let's now move on to using the iMOTION tools. Now that we have the tools and software downloaded, let's get started. First, we'll begin by opening MCU Wizard. The tool will open to the welcome page where you'll do one of 2 things. Either you will create a new system configuration file for your controller using a parameter template, or you'll open a system configuration file that you downloaded from the MADK webpage. Since I am using MADK with my design, I will be opening the .mc2 file for this evaluation board controller and power configuration. Here on the left, you see a nice description of the boards. And since I have not made any modifications to the boards, I will select default hardware setting for new user. Clicking next will bring us to the configuration options. As you can see, all the parameters are defined already and grayed out. If you would like to change a parameter, for instance, the switching frequency, or if you want to enable the scripting engine, you'll need to go back one step by clicking the previous button and change to Customize Design for Expert User. I want to show the scripting functions later in this video, so I've selected this to enable scripting and options. As you can see, a window pops up warning about pin assignments and scripting, which I will click OK to, and then put the design setting back to default. After the options page, you'll be taken through the process of entering all the required motor parameters for your motor system. Each page is one question and starts with more basic questions like the motor name, the rated current, the number of poles, and then it will jump into more detailed parameters like the motor stator resistance, LQ inductance, and as you can see, each question includes a nice description as well as a picture to help explain what is required. Other parameters that you'll need to enter include the LD inductance, the motor back EMF constant KE, as well as information about the motor speed like the max, and so on. If the description is not enough, we do have additional material that you can refer to that I'll link to at the end of this video. If you'd like to see how many questions are left to answer or to jump back and forth between, you can select the drop-down list above. The list starts with the welcome and option page and then includes all the required questions that need to be answered. Since we are using the default settings, there are only 14 questions that need to be filled out. Additional questions include the minimum running speed, speed ramp rate, the open loop speed ramp rate if used, the parking time, the low speed threshold, and finally the low speed current limit. Once you have filled out all these questions and select next, you'll be taken to the script edit page. Since I had enabled scripting in the beginning, this page is not grayed out. Depending on the controller you use, various analog and GPIO pins can be selected to be used in your script functions. The ADC pins are read-only, while the GPIO pins can be defined as input or output. At the bottom of the page, there's also a pinout diagram for the controller you are using. The script source code is defined in the Script Coding tab. Tasks can be created to read or write various pins as well as the MC parameter registers. More details on this can be found in the software reference manual and also the script application note that I will link to in the end. By default, the script source code will be saved along with motor parameters in the system configuration file, but you can also save the script source code as a separate file to open later or compile it for MCEDesigner here. If no scripting functions are desired, then you would just ignore this page and click Next. The Advanced Modes page is basically a summary of all the options and parameters you have specified in the previous pages. When you become a more experienced user, this is a great page to be able to quickly change and edit when the descriptions are no longer needed. If I click the System tab, you'll be able to see all the parameters related to the motor drive system. As you can see, they are all grayed out since we are using a default design with MADK. Going back to the Motor tab, you see the 14 questions you have just answered, and if you hover over a question, you can also view a short description. Scrolling down is all the additional questions that did not need to be answered, but can still be viewed. Clicking Next will bring you to the last step for MCEWizard. This page is where you verify all your inputs that you have entered, and then also generate the actual motor parameters and save them to a text file that can be exported into MCEDesigner. If there are any errors in the verification process, it will be highlighted in red in this window. To calculate and verify, click here. Since I had scripting enabled, a window pops up that is basically letting me know that the script compiled and also saved the script file, as well as the map register file, to the last known directory, which happens to be my desktop. As you can see, I had no errors and the entries have been verified. I can now export the text file of my parameters for MCEDesigner. I will just name this file Motor1. Okay, so we are now done with MCEWizard and the tool can be closed. I highly recommend you save your system configuration file so all your entries that you have just done will be saved and that you do not need to repeat the effort if you want to make changes later in your design. And that's it for MCEWizard, so let's move on to MCEDesigner. Let's now open MCEDesigner. The first thing you will need to do is open the MCEDesigner configuration file that you downloaded in the controller's MCE software package. If your computer is not yet connected to the controller, you will get a COM port error like I did. Connect your MADK control board to your computer now by using a micro USB cable, and provide power to it by plugging in your MADK power board to an AC source like the setup I showed in the beginning of this video. Now that I have it all connected, I will click Retry to see if MCEDesigner will now recognize the device through the defined COM port. Since it still does not connect, I need to change the COM port in MCEDesigner to the one being used for the controller. To do this, select Cancel and change the COM port by selecting Preferences, then Connection. The status of your connection is viewed here at the bottom left of MCEDesigner. As you can see, my connection is now good, which is shown with a green light. Next, you'll need to program the controller with the firmware and the latest MCU software package you downloaded, as well as the parameter text file you created in MCU Wizard. You do this by selecting Tools, then Programmer. This is where you would also download the compiled script file if one was created. First, I'll select the parameter file I just created in MCU Wizard called Motor1. And then I'll select the firmware file for the controller I'm using that I downloaded off the website. Click Start to Program. Once programming is complete, you'll need to update the parameter values in MCEDesigner configuration file by clicking Yes, and then selecting Update All. So now your controller is programmed and we can run your motor. The motor status is monitored at the bottom of MCEDesigner. As you can see, it is currently not running. Motor faults will also be viewed there, and if there is a fault, it can be cleared by clicking the Configure Motor button. The motor is run by clicking the green light signal. Unfortunately, you cannot see my motor, but it is indeed running, and you can see that with the status at the bottom. So now let's monitor our motor through the live traces offered with MCEDesigner. To view these traces, we must open the system window by selecting Window and then System. Since I want to view the motor and system window at the same time, I will cascade these windows and then resize them to be next to each other. On the right in the system window, we see the real-time traces of the available motor parameters in MCEDesigner. These functions are like using a virtual oscilloscope. As you can see, there are quite a few groups of traces that have already been defined, and a new group can also be defined by right-clicking Monitor Definitions and then clicking Create New Monitor Group. But for now, let's just view one of the existing groups. Double-clicking one of these groups first opens the trace setup window, which gives you the option to change things like the input sources, the scaling, sample rate, the trigger level, the trigger mode, and so on. Selecting OK will then open the graph to view. Here we are viewing the U-phase current and the motor speed in RPMs. This graph is actually very useful to debug the speed up or acceleration of your motor, which I'll demonstrate in a moment, but first let's just go over the functions of this graph. Channel 1 in yellow is our phase current, and then channel 2 in green is our motor speed. As you can see, the graph right now is set to auto scaling, which continuously updates the axes to fit the two traces. To better view, I'm going to change to fixed scaling and then change the axis values so the two traces are not overlapping with each other. You can now clearly see that my output phase current is about 50 milliamps peak, and then the motor speed is approximately 6,000 RPMs. Additionally, there are cursors you can use to measure these two channels. These cursors can be moved around to measure wherever they're placed, and then they can also be turned on and off. But for now, let's leave channel 2 on so I can use it when tuning the motor speed up. Lastly, the traces can also be paused, which I'll show you how this is useful in a moment. So now that we know how to use the real-time trace graphs, let's attempt to tune the motor speed up as one example of how you can use MCEDesigner to tune and debug your motor drive. First, let's see the motor's acceleration behavior. This can be done by double-clicking the reference speed in the Motor 1 window. Here I'll set the new target speed to 16,000 RPMs and click OK. I have paused the graph as soon as sped up so we can review the trace. First, looking at our speed, you can see it heavily overshoots the target speed of 16,000 RPMs and then oscillates until smoothing out. This underdamped response is also reflected in the current, with the peak reaching nearly 200 milliamps at one point. This would be considered a bad speed up as it draws a lot of current, which could damage devices, as well as overshoots the target speed, which could damage the motor. Thankfully, we can use MCEDesigner to easily tune our motor drive parameters to eliminate this overshoot. First, let's unpause the graph and then set our target speed back to 6,000 RPM so we can redo the acceleration. Now looking back at the Motor 1 window, there's a set of functions called Test and Tune. Since we're using speed loop control, which we defined in our MCU Wizard file, we'll use this function to tune our motor parameters. Opening the drop-down for speed regulator, we see 4 different parameters that can be adjusted. Opening the properties by right-clicking provides a definition of what each parameter is. KXSReg is the integral gain of the speed regulator, and for this case is the parameter which would be the most useful to tune. The value is also adjusted in the properties. Currently, you can see it was set to 100, and let's drastically reduce this value to 2 to see how it affects the speed up. For the change to take effect, you must double-click the speed loop tune function to execute. Let's now increase our speed back up to 16,000 RPMs to see how the trace looks. With the new integral gain value, there is nearly no overshoot or oscillation, and the motor increases to 16,000 RPMs quite well. Also, looking at the current, our peak is less than 150 milliamps, which is much better. The speed up is still not optimized though, as it may be a bit overdamped now, but this is just an example to demonstrate how the motor drive parameters can be tuned with MCEWizard, and I do hope it gives you a starting point to be able to tune your own motor in the future when you use these tools.